All right, the next section we are going to be doing is 8.1.3, the washer method. Hope it's stuck in your head now. So, in 8.25, we have a region that is bounded by the y-axis, and the lines y equals x and y equals 4. So we get this nice little triangle here. We're going to describe the solid that is formed when we rotate this around the x-axis. So if you rotate it around the x-axis, we're going to end up getting a shape like this and like this. So the figure here is a cylinder, but we are not counting the inside, so this is going to be a cylinder with a cone removed. It says using geometry, we're going to calculate the volume of the solid. So in order to calculate a cylinder with a cone removed, that is going to be the volume of a cylinder, which is pi r squared times height. And if we remove a cone with the same height, that is going to be 1/3 pi r squared times height. In other words, we get 2/3 pi r squared times height. That's the volume of the cone, or the cylinder with the cone removed. So what is going to be our radius? Our radius of this is going to be 4, and our height is going to be 4. So we could just plug those both in. 2/3 pi 4 squared times 4. 4 squared is 16. 16 times 4 is 64. 64 times 2 is 128. So we get 128 pi over 3. So that geometrically is how we can find the volume of our shape. However, we're going to do this using calculus, right? So in calculus, we're going to determine the volume of the solid by looking at a typical slice. Now, if we look at the previous one, it was when we took the slice of the figure, we end up getting discs. But this one has a hole in the middle, and that's why it's called a washer. It resembles the same shape that you would take a nut and a bolt, and you would put the washer in between them. A washer just looks like a disc with a hole in it. So we're going to write down the volume of this washer using our length of the entire radius, and we're going to subtract the length of the inner radius. So our volume of our washer is going to be pi. The entire thing is a radius of 4, so we're going to do 4 squared. We're not going to do any dimensions. We're just going to be talking about one-dimensionally, so of the circle with a circle removed, and we're going to subtract whatever our radius is. So we could say x squared, I think, because our line is y equals x, so we could say pi x squared, or we could say pi r squared. Now we're going to calculate our volume using an integral. So using the fact that we have this as our volume of one of our circles, we can use our integral notation. So we are going from 0 to 4. And we can represent this part here. That's going to be 16 pi. We are going to subtract our pi and our x squared. So we're going to say x squared, and we'll say dx. And now we're going to just put that into our calculator, so you could literally just type this in there and calculate the integral, which will give us approximately 134.04. If we take that number and we divide it by pi, or we divide it by pi and divide it by 3, so we could take those out, we will end up getting the same number. We'll get 128 pi over 3. So, but I want you to go ahead and plug that into your calculator to go ahead and make sure that we get the same value. So go ahead and pause, make sure that all makes sense. Okay, and now we're going to go on to 26. So we are going to sketch the region described by the boundaries below, rotate each of the region around the indicated axes, decide if horizontal or vertical rectangles should be used to calculate the volume. Then we're going to set up and evaluate an integral to determine the volume of each revolution. So I saved us some time by graphing each of these. So we have x plus 3 is this red one. We've got x minus 3 squared is this blue one, and then x equals 0 is going to be the green one here. So we end up having this shape. So we want to rotate this around our y-axis. So what is that going to look like? Well, here, and we end up getting this little top guy. So if we were to calculate the volume of this, then we can take this cone and add it with this cone. And those two cones are going to be made up of a bunch of disks. So we're going to add two cones together. So since we're going to be talking about the cones that are having we have circles that are stacked on top of each other like this, that means that we're going to have to do dy instead. And since we're going to be doing dy, we're going to be doing disks that are lined up horizontally, that are stacked on top of each other. We're going to have to rewrite each of these functions in terms of x instead. So we start off with this one here. If we were to rewrite this one, we're going to solve for x basically. We're going to take the square root of both sides. So we get plus or minus the square root of y. And then we're going to add 3, so plus 3, and that equals x. And then the other one is we can just subtract 3. So we get y minus 3 equals x. Now, do we want a plus or minus? Well, I saved some time by graphing positive square root of y plus 3 and also negative square root of y plus 3, and which one actually represents this part here. So which one actually represents this blue part? Well, it ends up being the negative y plus 3. The positive one would produce the other side, which is what we don't want, which is this side. We don't want that side. We just want this side. So we only care about this as our formula, our representation of the part that we care about. So if we were going to find the volume of just this part here, then we are taking the blue part and we are adding it to 0. So we're going to go from negative, or from 4 to 9. So we're going to go from 4 to 9 because that's going to be our height that we're going to use. So we're going to take the integral from 4 to 9 of pi r squared, so pi, but our radius is going to go here. So our radius is to the blue line. So pi r squared, so I'm going to say negative square root of y plus 3 squared. Dy, because that's going to be our radius. So our radius is of this circle here with a radius of negative square root of y plus 3, and we'll say dy. And then we're going to add that to this cylinder below, because we're going to have to take two integrals, the first one being this one and the second one being this one. The second integral is going to be our this function, the red function, so y minus 3. So our second integral is now going to go from 3 to 4. So we're going to have to go from 3 to 4 pi, and our radius this time is going to be y minus 3 squared and dy. So once again, I want you to go ahead and pause that. Go ahead and type in this entire integral, type in this entire integral into your calculator, and get a sum. Add those two together. All right, so I did this earlier, and I got 5.57 units cubed. Let's go ahead and look at our second example over here. So once again, this time we're going to be rotating around the x-axis. So this is kind of weird. Let's represent what this would look like rotated this way instead. So we end up having a point here, a point here, and a point here. So if I could draw this, and then we're going to rotate this around. So let's see how this will look. So what is going on here? We end up getting a disk that looks like, one of them may look like this, and then another may look like this, and then another may look like this, and it's getting smaller each time, right? Actually, and our circles are getting wider each time, I guess. So, I don't know. Bad drawings, but I hope I can show that's what it looks like here. So we have a bunch of disks stacked on top of each other, and now we're going to be actually doing dx instead, because our disks are going horizontally in terms of our change in x. So we have our equations, and they're in terms of y, so that's okay. We don't need to change anything. Let's go ahead and do our area of our big disk. minus our small disk, or our big circle minus our small circle. So we only have a distance from 0 to 1. So that's what our integral is going to be, from 0 to 1 of pi r squared. Our big radius is going to be our blue graph. And then our small radius is going to be our red graph. So our blue graph is the parabola. So we're going to say pi x minus 3 squared, because pi r squared, dx, that's going to be our big circle. And then we're going to subtract our small one. In fact, we could write this as one integral, but I'm going to go ahead and write it as 2. So we're going to subtract our small circle, which is going to be pi r squared, and our radius of this one is going to be x plus 3. So we'll say x plus 3 squared dx, and go ahead and type that into your calculator. Pause this video and see what you get. Okay, I got 93.829 units cubed. And that is it for this lesson. I'll see you later today. If you have any questions, here's going to be your assignment, just 2 problems.